The issue of time ordering is really all about establishing the direction of causation, figuring out what causes what. If X and Y are correlated, significantly correlated, that still leaves open the question of which way the arrow of causation points. You might think X causes Y. You might think the causal relationship looked like this. But how do you know for sure that the causal relationship isn't in the opposite direction? Maybe Y causes X. How do you tell the difference? That's the issue involved with proper time ordering and establishing the direction of causation. Sometimes it doesn't make any difference because you already have a pretty good idea of which variable changes first and which variable changes later. And that's the reason we refer to this as proper time ordering. Causes change before their effects. If X really causes Y to change, variations in X cause variations in Y, then you would expect this to change first and only later that to change. Causes, variations in causal variables, occur first, and their effects on other variables occur only later. Causation doesn't work backwards in time. Now, that seems pretty straightforward. But in the real world, that requires a lot of effort to actually see whether that's really true for the variables you're studying, and sometimes it's very difficult to tell the difference. What that means in terms of methodology is that somehow you have to figure out what's causing what, which way the arrow of causation is running. Well, let's just give you an example. Let's say that you believe that increases in poverty in communities leads to increases in crime. In other words, more poverty, more crime, a positive correlation. You do your research, sure enough you find, when you gather your statistics, that these things are positively correlated. Now, you're assuming that's the way the arrow of causation runs, but what if it's the other way around? What if more crime somehow produces more poverty? If you think about it, it may not be as weird as it sounds. Because, frankly, neighborhoods that have lots of problems with crime often have a lot of other social problems as well. Crime and these other problems may drive out businesses. I mean, after all, you drive through these neighborhoods, you see bars on the windows, you see abandoned businesses, and basically it just doesn't support a lot of good economic activity and a lot of jobs. So maybe crime chases away income and produces more poverty. Maybe crime causes poverty on a community level. Or at least maybe that's more true than the idea that poverty causes crime. How do you tell the difference? How do you tell if it's this or that? Well, you have to design your research accordingly. Now, there's different approaches. With crime and poverty, you're probably going to have to go into the real world and gather data, which means that, well, you're not going to be able to do it in a laboratory. You're going to have to gather data, make observations and so forth, and then somehow use statistical analysis to try to root out whether this is true or that's true. To do that, you're going to have to use what is called longitudinal research, gathering data over an extended period of time on both of your variables. And again, using a variety of statistical techniques and tricks to try to figure out whether this is changing first, and then later you tend to see changes here with a lag, or is it the other way around? Is the tendency for this variable to change first and only later for this variable to change? If that's the case, this is true. If it's the opposite case, that's more likely to be true. In other words, you can use statistical techniques to try to pull apart the long-term time patterns in the data and try to figure out which way the arrow of causation is pointed. Alternatively, with other kinds of topics, you might be able to take people into a laboratory, perhaps do true experiments, or maybe even out in the real world do quasi-experiments. In either case, the trick is that somehow you can control what order in which people are exposed to the variable. In a laboratory, you may be able to expose them to variable X, and then later measure another variable Y. Just by the way you're doing your experiment, you're controlling which comes first and which comes later. And that allows you to test whether this is really true or maybe that's true. Sometimes in the real world you can do something similar. So for example, if you have, I don't know, a poverty program that randomly picks different people. Some people are accepted into the program, some people aren't. What's critical is that people are randomly assigned at one point in time. And then later, maybe years later, you compare these two groups of people and you try to find out whether one group really has lower rates of poverty at a later time. Was exposure to the program at time one, did that lead to less poverty, perhaps no change, maybe even increasing poverty? You can figure out the effect of the program on people's later rate of poverty. Well, that's kind of like testing a causal theory. It's the same basic logic in terms of establishing proper time ordering. And you can use the same basic tricks. Those are called natural experiments. But what those basically involve is, at one point in time, something happens, and then later you can see how people react or respond. You can measure how it affects other variables. In any case, what you're really trying to do is use a variety of different techniques and procedures to study the time ordering of how variables change, which variable changes first, which variable changes second, and you're doing that in order to establish which way the arrow of causation points, what causes what. Now, the last thing that we're going to talk about in terms of testing causal theories for right now is the issue of eliminating spuriousness.